I want you to actually go to this part of the process, this exit, log it and exit. So it's almost like interceptors for the rules. And my rules are constantly monitoring, and then they can stop the process and say, stop whatever you're doing, log and exit. So it means you can now declaratively define rules that monitor your entire process without having to model them explicitly in your process model. But it gets cooler than that because we can have, our system emits events. So every time you start a process, every time a rule fires, that's emitting an event. We can have the engine listen to itself. So if you've got a process that starts 10 times in the last minute, maybe there's some fraud detection, the engine can be adaptive and it can switch out on the fly to do a more exhaustive process which has got some fraud detection at the beginning. So that's pretty cool. We've got an engine that's listening to itself and adapting to itself, that's using its own event processing capabilities to monitor itself. We have domain-specific processes. So that means we can define custom palettes, and there's an API for this. It takes about an hour to do one. And here's example one where we have a finder, goes to disk, iterates each of the files that come back from disk, logs them, has some rules to check what goes on in those files, zips them up, copies them somewhere, and emails them. And these domain-specific processes support customizable editors, and it's a very slick API to start to do domain-specific processes. Here's one. This is where this Chris is the brainchild for this, and it came from medical diagnostics, where domain-specific processes is very important for the medical field. And this is one of the early prototypes that he did while developing this technology for medical research. Of course, we support fully interactive debugging, so you can have breakpoints, and the breakpoints you can look at your audit views. It tells you how you got there. That audit view shows you not just for your rules, but also for your processes. And it says the current execution is a full audit for your processes as well. It's all correlated, and when you have your breakpoint, it tells you where you are at the moment, and it shows you the state of your workflow. So you've got debugging in your workflow, you've got deflogging in your rules, with fully correlated audit reporting. And the correlated audit reporting is actually very important for historical purposes as well, because if Sarbanes-Oxley comes in and says, how did you make this decision? And you go to your rule engine, and you go to your process engine, and you go to your event processing engine, and then you've got to figure out at this point in time, you've got to correlate all of these. And that's a lot of work, and you're going to have a dedicated guy just writing software to correlate these reports. With Drools, you get that for free. So this is Chris, he's the Drools Flow guy.
Yeah, I'll just give you a simple example. Where we're combining rules, where we're combining processes, and we're combining event processing just to show you how it all works together. This is the overview, this is the general process which shows how you could process an order. In this case, we're validating the order, and if it's not valid, we'll send an email back, and if it's valid, we'll apply possible discount rules, we'll handle payment, we'll handle shipment, we'll handle follow-up, and that'll end the process. Now, there are rules hidden in this process. For example, validation will be handled by rules, discount will be handled by rules. Let me show you that. So for example, these are discount rules using our domain-specific language. So you can have like natural language rules, which specify, in this case, that if there's an order between 22 and 23 hours, we give an additional discount percentage. You can define your own domain-specific languages so that you can specify rules which are readable by business users. This is just a simple example of how you could specify discount rules. Just to show you what would happen if you start executing this. I just started executing this process, and well, this is what happens. Now you're probably wondering what's going on. Let me show you what's going on. So we can show you in a debugging view the rules that are executing, the processes that are executing, and what's actually going on. So in this case, this is the debugging view where you'll see that the process which is currently executing is now waiting in this step. So the validation works fine, the order was valid, we applied the discount, and you'll see that we're waiting for a follow-up. So follow-up is just a human task, which is delegated to a human task service. So if a user now logs in, and he'll see a task pop up in a task list so he can complete it. So that's what's going on the process side. You can also see what's going on, what already happened. So this is an integrated view of what's going on. So you'll see that we started the process, actions have been executed, rules have been executed, and that it's currently waiting in the order process node for a user to complete that task. So if you start debugging your application, you'll see that you'll have an overview of all your rules, all your processes, and that integrated in one view. And just to show you a simple CEP processing rule, we have a very simple rule which will check whether more than 10 orders are currently executing at the same time in the engine. And you'll see that in this case, if we start a batch of processes, from the point on 10, we started noticing that a warning message has been entered. So your CEP rules, which are actually monitoring the engine itself, can then define what should happen. In this case, we just show a simple warning message. But you can use it to adapt your system based on the events the engine itself is generating, and adapt your entire business logic based on what's happening at this point.
Just going to go over the last bit, which is about comparing solutions. So one of the things we try to do with the Drools business logic integration platform is, if you've got your rule engine, and you've got your process engine, you've got your event process engine, each one's got its own API. Each one has its own language. Each one has its own deployment mechanism. And you learn one, that can take you a couple of weeks. You've got to stop, you've got to learn another. It's a completely different API. So you're learning something that's pretty much doing the same, but it's a completely different way, because obviously completely different vendors. So one of the things we try to do is reduce the amount that you have to learn. So you learn something once, and it applies to your rules, applies to your processes, and applies to your event processing. And that means we're trying to enable you to do more by learning less, which saves you time and money. So if we look at a building, so for instance, you have if we take 3 different solutions, JBPM, Jess, and Esper, 3 different products you have to use. Each solution on its own is fine. There's nothing wrong with these solutions. It's just you've got to learn 3 of them. So in Jess, I've done each one loading from file. So in JPM, you have to grab a new file. You're going to use a static method, and you're going to build a process definition from which you're going to pick a process instance. Jess, you're going to create a new RETI. You have to create a file reader. You use the Jesp engine. You're going to pass that. On Esper, you use the default provider, and you create an EPL. So each one of those there's no consistency. It's just, there's nothing wrong with each one, but it's just different. Everyone's different, and you're going to have to learn the intricacies and the annoyances with each one. So Drools, we have this idea of everything's knowledge-oriented. We have a knowledge-oriented API. So first of all, we create a builder, and the builder is going to load the flow. We use the resource type to indicate the type. You check for errors, and then you create the base, the knowledge base. So that's how I do it for flow. And I want to do it for rules. The only thing that changed was the resource type. Everything else is the same, so you learn it once, and it does it for everything. For us, event processing is just an extension of the rule engine, so there's nothing extra to learn. So you've already removed one step. Not only have you simplified the other 2 steps. We take this a step further. Because we have a fully integrated way of loading your definitions, we can then combine this to our deployment descriptor, which is called a change set. So these change sets allows you to take different types of resources and deploy them in one go. So I've got a rule flow, a DRL technical